Okay, we are moving to the next section. And in this section, we're going to talk about complementary events and odds. And to start, let's consider what is the probability of rolling a 3 on a single-sided die? We did this in a previous video, so you may remember that the probability of rolling a 3, this is the notation, is going to be 1 out of 6 because there's only 1 3 and there's 6 possible outcomes. The next question says, what is the probability of not rolling a 3 on a single toss of a die? So the probability of a 1, 2, 4, 5, or 6, because we want to not roll a 3. Well, there's 5 sides that aren't 3 out of 6. All right, do you see how these are related? We have 1/6 for the event and 5/6 for everything that is not the event. They sum to 1. If I add them up, I will get 1. These are called complementary events. The complement of an event is the event E, so we're just calling the event E. The complement of that event is E does not happen. What you saw in this warm-up problem was that if I add the probability of the event plus the probability of its complement, to write the notation of complement, I'm going to still use the same letter that we use for the event, which in this case is E. And then I'm going to put a tick mark right there, or an apostrophe that signifies this is the complement. If I add those together, I get 1. If I have only one of these probabilities, I can figure out the other. So what this means is to find the probability of the complement, I just do 1 minus the probability of the event. Additionally, if we want to find the probability of the event, that is equal to 1 minus the probability of its complement. Now let's do some example problems. So problem 1, if the probability is 1/3 that it will rain today, what is the probability that it will not rain today? These are complementary events. So the probability that it will not rain today is equal to 1 minus the probability that it will rain, which is 1/3. Now, just a quick reminder, when adding and subtracting fractions, we need a common denominator. So this 1 whole turns into 3/3. I'm going to subtract 1/3. And when subtracting or adding fractions, the denominator stays the same. I subtract the numerator, so 3 minus 1. This is going to be 2/3, which is approximately equal to 0.6667, which is equal to 66.67%. This also shows us that there are 3 ways to express probability. It can be a fraction, a decimal, or a percent. Okay, let's do a few more. What is the probability of not rolling a 5 on a single toss of a die? Now, I know you could probably figure out the answer to this without using the complement rule, but we are learning the complement rule, so we're going to keep going with that. This is going to be 1 minus the event, which would be the probability of rolling a 5. 1 minus 1/6. And to show you the arithmetic one more time, 1 whole becomes 6/6 minus 1/6. This is going to be 5/6. Problem 3 says you are dealt 1 card from a standard 52 card deck. Find the following. If you are unsure of what is in a standard 52 card deck, there is several images out there on Google that you can find, or there is a link to a PDF in the Canvas modules. And it's also available on several pages in your notes. Problem 3A says to find the probability that you are not dealt a face card. The face cards are the picture cards. Probability of not drawing a face card is going to be 1 minus the probability of a face card. So this is 1 minus, there are 12 face cards in a deck, so 12 50-seconds. And just a reminder that 1 whole becomes 52 over 52 minus 12 50-seconds. This is going to be 40 50-seconds. And then we do need to simplify to be 10/13, or put it in your calculator and get a decimal. Problem 6 says to find the probability that you are not dealt the 6 of hearts. So probability of not being dealt a 6 of hearts, that is going to be 1 minus the probability of the 6 of hearts. So this is 1 minus, there's only 1 6 of hearts in each deck. So this becomes 52 50-seconds minus 1 50-second. So 51 50-seconds probability that we are not dealt the 6 of hearts. So pretty likely that we aren't going to get the 6 of hearts. Then finally, find the probability that you are not dealt a diamond. So probability of not a diamond, this will equal 1 minus the probability of being dealt a diamond. So 1, then we just need to subtract off the probability of being dealt a diamond. Well, there's 13 diamonds, so that's 13 out of 52. And one more time with the arithmetic. 1 whole becomes 52 50-seconds minus 13 50-seconds. This will be 39 50-seconds, which equals 3/4 or 0.75 or 75%. And that is our introduction to complementary events.